Today we are going to look at, we are still on the solution to solution of differential equation, okay? And today we are going to look at the form dy dx, which is given as f of x times f of y. What it means is, initially or in my previous videos, we did look at differential equation which the dy dx is equal to only f of x or only f of y. That is, the functions is only what the differential equation, the dy dx is equating to only f of x or only f of y. But here in this case, the differential equation is given as equal to f of x times f of y. Okay, so the y and then x are all joined together in the same equation. So how do we do it? Here we use a method called separation of variables, okay? Because these two variables are put together in the same equation, what you need to do is to separate them on the sides. You put one of the variables on one side of the equation and then the other variable on the other side of the equation. Then you differentiate and you go your way, okay? You do what we call direct integration, then you go your way. That will be all. So we have this question which says that dy dx is equal to 3x squared minus 2 all over 2y minus 1. So how do we do this? First of all, we have to separate variable. So separating the variables is the first step in the solution of this equation, okay? So here what I will do is I will multiply the equation by 2y minus 1, okay? And I'll also multiply the equation by dx, okay? So what I mean is, here I will multiply here. If I multiply the equation by 2y minus 1, you realize that we have 2y minus 1, okay, into brackets dy, okay? And if I multiply here by the same thing, 2y minus 1 will cancel 2y minus 1, okay? And I will equate it to, and I'll also multiply through by the x. When I multiply here by the x, that dx will cancel this, and that dx will come and multiply by 3x squared minus 2. So this is what you will be having, 3x squared minus 2 by the x. So after this, you realize that all the variables over here are in x, and then all the variables here too are in y. So this is what we mean by what? Separating the variable. So after that, then you do direct integration. So integrating this, we integrate this one individually. We integrate 2y, then we integrate minus 1. Here too, we integrate to a 3x squared, then we integrate 2 here. All right, so by integrating 2y, we'll be having 2y squared over 2 minus, when you integrate 1, you get it. Since we are integrating in terms of y, you get what? Y to be equal to, when you integrate 3x squared, we get what? 3 over 3 x to the power 3 minus, when you integrate 2, you get what? 2x, then plus c. Plus c means that we have what? An arbitrary constant which we are dealing with, since we don't have the limits of the equation on the board. So now what we do is we do simple arithmetic, we do what? Simplification. We have 2 here and it will cancel this 2, and then this 3 will also cancel this 3. What do you have for cancellation again? None, okay? So our answer will be in terms of what? Y squared minus y equal to x to the power 3 minus 2x plus c. So this is what we'll be having as our solution, equal to x to the power 3 minus 2x plus c. And this will bring us to the end of the solution for the question on the board. We have the second question on the board, which says we should solve the differential equation y squared minus 1 dy dx equal to 3y. Now, just like we did for the first one, all we need to do is to move all the variables that are involved in this equation, the same one, that is y on one side and then x to be on the other side. If you look at the question, we have y here and then we have y here, so it means we have to move, either we move this to this side or we move this to this side. And to make it easy for me or for us all, we have to move the one which is on the right hand side to the left hand side, and the x's will also go at the right hand side of the equation. So without wasting much time, all we need to do is to divide both sides of the equation first by 3y. Okay, so here we have dy, and then multiply both sides of the equation by dx. So when I multiply here by dx, the dx here will cancel the dx which will be used to multiply, and then it will equate to what? Just dx. So here it is assumed that we are left with what? Just 1, and then that one would just, this one will just be there. Okay, so here to make the thing simple, we will have to what? Divide all the terms in the bracket here by this 3y. Okay, so we have what? Y squared over 3y minus 1 over what? 3y. Okay, then the dy, I'll put all of them in a bracket, and this one will be equal to what? The x. Okay, so from here, to make the integration simple, all right, here one of this y will take care of one of this y. Okay, so then the solution will be, and then I can factorize. Okay, so before that I have y over 3, okay, minus 1 over 3y. Okay, dy over equal to what? Dx. Okay, so from here I can factorize 1 over 3 out. So 1 over 3 out into bracket. Here it will be left with just y, and here we'll be left with minus 1 over y, which is dy, and it will be equal to what? The x. So from here, then I do what we call the direct integration. Okay, so I will integrate here, and I will also what? Integrate here. So by direct integrating, I'll have from here, I have 1 over 3. Okay, so when I integrate, I'll put it into back. When I integrate y, I'll be having y squared over 2. Okay, minus, when I integrate 1 over y, I'll be having ln y. Okay, and then into bracket, that will be all equal to, when you integrate the x, you get x, then plus c, which is the constant of integration. Okay, so over here I can decide to multiply the 1 over 3 by these ones in the bracket. Okay, so 1 over 3 by this, I'll have what? 1 over 3 y squared, 1 over 6 y squared minus 1 over 3 ln y equal to x plus c. Okay, this will bring us to the end of the solution to the differential equation of the form dy ds equal to f of x times f of y.